We're going to get started here in just a few minutes. Hello everyone. So we're gonna get back started doing work. So let's get all the things online. So we did fix a few issues off camera yesterday. One of which was Fat Sack was colliding with himself and putting himself on top of himself, and that's why he was flying off into space. Which is always funny. It's kind of like, what was that one guy in Final Fantasy that could suplex himself when he got confused? Yeah, it was kind of like that, but with Fat Sack. Hello, Karkan. How are you today? I'm doing well. Just woke up not too long ago, so just kind of getting started here. And one of the big things that we got to deal with to start with here is it looks like we broke the nightly build yesterday with what we were working on. So let's see exactly what was going on there. So it's all pissed off about our enabled trace collision. So that's going to be Dashkin game mode 38. So it's not happy about this. Why would it not be happy about that? Anyway, why don't we just try getting rid of it? Let's see what we can do. Hey, Ishu. We're just getting started on working on all the things. And of course we're going to start it off by compiling. But we're trying to fix this build. It shouldn't be too bad. So, looks like we can just remove that line, so we'll try that out. An affiliate invite? Is that for... What is that for? Is that for Twitch? Let's see, what do you have to do? You have to have at least 500 minutes in the last 30 days, 7 unique broadcast days, an average of 3 concurrent viewers or more, and at least 50 followers. Well, congratulations. So let's see if our trace is working properly. Yeah, it looks like it's working, so we can just go ahead and fix that. And if you did notice, Fat Sack started on the ground, which is what we were working on yesterday at the end of it. I fixed that. I did that. Anyway, let's go ahead and submit that fix to Perforce, and we'll go ahead and kick that build off again. So that should be running in the background, and it'll tell me if oh, one emote. Oh man, I'm waiting for that. What are you gonna? Do you have any ideas about what you're gonna make? All right, so I think we got the nightly build fixed. So now, what I've got written down is continue with movement physics. So, well, let's kind of just start over and get our bearings here. So what exactly do we need to do? We need to get our character moving around. So that's in our movement object. And we're going to start everything on the ground. So you want to get this character actually running left and right and stuff like that. Nice. So what exactly do we need here? Taking movement, exceeding, yeah, so we got some basic stuff here. So we should be doing our basic locomotion movement. Let's just see exactly which movement type we've got set up. Let's make sure he's on the ground to start with. It's always a bit slow getting back into working on coding stuff, and then you kind of hit your stride after a while. So we're just gonna work on that. So we are ticking our movement, which has been optimized to update flying. So we're setting it to none to start with, and then it looks like if we don't call set movement type, which we're not calling anywhere, nothing gets set. So let's go to that one method we had that supposedly puts us on the ground. So we got move object. We've also got discover physics state, and do we have two variables that are controlling this current state? Is that what's going on? Oh, we've got movement type, and the movement type is flying. So we actually want to change our movement type as well here in our discover physics state real quick. So we'll set movement type. And Fat Sack is a locomotion man. He's like a train. He's gonna locomote everywhere. Well, that would be pretty awesome. We're waiting at the train station, just a big Fat Sack runs by. Just like, what the hell was that? Yeah, it's starting to not be winter around here, so I don't have to wear a whole bunch of heavy clothes just to work in my basement. It was always just freaking freezing in here. which will be nice in the summer because now it'll be like nice and cool in my basement. So, good times. Yeah, so let me know if anything's messed up on the stream, like all the things such as Ishu donated $25. What is going on here? That is amazing. Thank you. You were my first donator. So, congratulations. And I'll go straight to helping out on Dashkin. Well, we'll throw that at some music. We'll be hopefully working with some pretty awesome composer talent, and that's gonna cost some money to do. That's one of the things we really want for Dashkin is a great full soundtrack, because the music and all the animations has been just a big part of it, and we want it to continue to be a big part of it. Alright, so we are flying. That's just the initial movement type, so when we actually hit play here, we are setting it to flying again, because that's kind of our default for our biped. Did we set that afterwards? Yeah, well, we're working on that. You know, we're gonna keep streaming until we're the most popular channel on Twitch, which means we're gonna keep streaming forever. Because I will never be the most popular on Twitch. But you can know you were the first person to support the cause. All right, so we got locomotion movement rolling along here, and we're actually updating with our movement. So excellent, we've actually got our locomotion movement going. Oh yeah, well, I'm trying to like set it up so I just stream like work during the day, and then try to in the evening stream a few games and stuff like that, which would be pretty awesome. And try to remain consistent while we're working on Dashkin. So like every day or every other day at least, we got something getting put out there whenever I'm working. So what were we writing down yesterday? We got the big states, like we're stuck on a wall, if we're currently falling or moving in the air, or if we're on the ground. So, and we were gonna basically say that we're on the ground. So we're gonna have to do a switch here, excuse me, based on our physics state. So we're gonna switch off of our current state, and we're gonna do update locomotion on ground. IntelliSense is actually working today. So what we're going to want to do is, we've got a few rules here where we're not always going to be simulating the whole thing. So if I remember properly, it was we're returning how much time was actually simulated. So what we want to do is we want to, again, we're going to be like returning update locomotion on wall, and the loop that's parent to us is going to actually then call us again if like we need to simulate another tick, especially if it's another type. So we got on ground, air, and none in defaults. And for none, we're just going to return delta t because it's like, well, we didn't move, so not a problem. And we're not going to call move object. So all of a sudden here, FatSack's not going to be doing anything. A schedule would be good? Well, that would require me to be on like, you know, a reasonable schedule of waking up. And I have not been on one of those since working at Amazon. So that's also something that might help out. I might actually, you know, have a schedule. And that might help ground my life. So I'm not just always doing nothing. Alright, so update locomotion on ground. And update locomotion in air. So let's get these functions written out here. So do we have move object? We want to put it next to that. Alright, here we go. Ground and air. Yeah, that would be a totally different project if we had more people actually working on Dashkin right now and for the foreseeable future and all that. It's just me and Adam, so, you know, the work that, and Adam has, you know, he's got his full-time job there doing work for Bob's Burgers, so a lot of the work that's going into Dashkin is on these streams. Like, there's not a whole bunch else that's not, except for, like, you know, story stuff and stuff that can't be broadcast without spoiling things for all the fans. So, if it's not on stream, it might not exist. Alright, so we are going to start off with our ground-based locomotion. So what are our rules for that? We've got, yeah, and at least all my stuff has gone up on YouTube as well, in slightly higher quality, I think. And so the archives will be there forever. Everyone will be able to see all the horrible decisions we've made. And they'll be able to point to, like, this is the moment where they screwed everything up. They were doing so well, and then it all fell apart. Or, this is the moment when everything fit. And then we can make a documentary about how amazing we are. And because at least I'm a completely arrogant narcissist man, I'll watch it every day for the rest of my life. That's how I'll just start my day. I'll just watch, you know, the documentary about myself. Or do I already do that and I made my own documentary? Alright, so if we're currently stuck on a wall, that's not what we're doing. If we're currently moving in the air, if we're on the ground, okay. So we're going to need some information here. We're going to need the normal to the surface that we are on, and we're going to need the direction vector for moving along that surface. So, the normal to the surface, how are we going to actually get the surface normal? Well, let's pull up our handy reference here, which is paint. So if we're on something, that means that last frame that you know, our dude was on something. So what we should do is we should do a sweep downward with our object to get our collision point, and then our normal. No! No! Adam! Don't blow up. I need you. Alright, so we're gonna need the direction vector. Yeah, the movement direction vector. And that's gonna be, we're just gonna start off with 0 vector. And we're gonna need the normal, the surface normal. That's gonna be f vector 0 vector again. And there was another thing yesterday. Basically, FatSack can enter space, and when we were casting array, we were doing this like sweep component in a direction. We weren't. Let's see, sweep component. So when we were calling sweep component, basically what was going on was we weren't passing any parameters into our component query params, so our component was colliding with itself. So when you sweep a component and it collides with itself, my basic code here was just throwing it on top of itself. So FatSack every frame was teleporting himself on top of himself into infinity. And the camera was trying to catch up, so it was like, ah! But we don't have that problem anymore. So we are going to need to get all of our collisions. So we need the discover physics state. Yeah, we're going to need to get all these physics components as well. So let's get all of our physics boxes. And we'll probably be simplifying a lot of this code later in terms of, you know, optimizing things or getting rid of copy pasta. Turning these into like get surface normal and other things like that. Well, I mean, he already shot into space, so he's at least not shooting into space anymore. Maybe we'll have some Morgs that are mean Morgs that toss FatSack into the nothingness. Alright, so if you don't have any physics, what are we going to do? If you don't have any physics boxes, then basically, well, let's just return out. So if comps.num is 0, we're just going to return delta t, and let's print out a warning. So let's do warn log. There were no physics boxes for the entity you're moving. So we'll at least get some log spam telling us something's horribly wrong, because we'll also maybe fix that later and be like, well, if you don't have a physics box, we'll just move you. Actually, why don't we just do that? That's actually not an awful plan. So we'll just move object return. Move object returns the delta t, so we'll just return move object then. The hell with it. If you don't have a physics box, you're moving in whatever the hell direction we want you to move. Okay, so let's grab our surface normal. So what we are going to do is we want to grab the closest collision point below us. Alright, so it's going to be float closest point. So we're going to go through for every component and cast straight down. So sweep component, and our position is going to be our. Is it going to be the position of the specific component? Is there like a component like get transformation on there? Let's see, get position of primitive component Unreal. Let's see, is there transformation, translation? Well, it looks like it's just on the actor, so we'll just do that. So let's get F vector, our, let's just say start position. So that is our starting position. And let's do F vector down is going to be our down vector. That's going to be G down. So we sweep a component, we need a position, which is going to be our start position. And our direction is going to be down. Our distance is going to be this physics far enough. Pass in the primitive component and then our hit array. So let's do that. Let's say hits. So we just do comp and then hits. So this should also return true if there's an actual blocking hit, which is what we should have. So if we have a blocking hit, then we should be able to get it from the hits array. So we want to go hits, sub hits, num -1. That should always be the blocking hit according to the documentation. So this should be the blocking hit is this. So if our, let's not call this closest point, let's call it closest distance to floor. Yeah, floor, it has a W in it apparently. So if the closest distance to the floor is greater than blocking hit dot distance, then our closest distance to floor is going to equal it. And we're going to need the surface normal, aren't we? So surface normal is going to be our blocking hit dot. This is why you don't ever trust IntelliSense, because it just fails you whenever you actually want it to work. So let's see, what is on a hit result? Yeah, we got the normal and world space for the object that was swept. Impact normal. Normal of the hit in world space. So we actually want impact normal and impact point. So why don't we just grab that information and we'll see if we actually need it. So surface normal is going to equal blocking hit dot impact normal, and impact point is going to be blocking hit dot impact point. Why is this getting angry at us? It's saying the float is incompatible with that, so let's see if that's true. Yeah, we want sweep component dir, not sweep component. That's what it's giving us trouble about. Alright, cool. So basically what we want to do is we want to check here. So it may be that like the floor moved out from under us, or we moved at some point. So it's very possible that we didn't actually hit anything. So what we're going to do is we're going to say if our closest distance to floor is greater than or equal to this G down, then we didn't hit anything. And what we're going to do is we're going to return 0, whoops, and we're going to set ourselves to flying. Just be like, alright, we're no longer on the ground, are we? So set physics state. Alright, well that's not a function. Let's see. What is though? Get physics state? Oh, we just set it directly, don't we? It's probably not the best way for me to do this. I should probably make a private function for setting the physics state just right now. Just to kind of put it all in the same spot. That way if I'm ever like, where the hell am I setting this physics state? I can just see where I call the function set physics state. As opposed to looking where I set it equal to something. Real easy to miss those. So current state equals new state. Not bad. Let's see. Thank you for hosting, Karakin. Bring in all the viewers. You keep hosting us. I mean, you're like a big deal now. You're like a Twitch affiliate, so you're really bringing the numbers. That's very kind of you. We have our celebrity in chat here with Karakan. Alright, so we're going to call set physics state to in the air. So we must be in the air. So physics state in air. Excellent. Yeah, you're kind of a big deal, Karakan. I'm a little intimidated. So let's see. Okay, so if we are down here, we have a surface normal, we have all these things. So we want to see which direction we're going, right? So we have like a wanted velocity, I'm pretty sure. We have told this character that we just go over to our, I think we got our movement code up here in biped movement CC. And yeah, we're setting our wanted velocity on our movement. So we have our wanted velocity. Well, appreciated. So we've got our wanted velocity. Why don't we just say we're moving at that wanted velocity here real quick. So we'll do like acceleration later. So we're going to do f vector velocity, and we're just going to set it to our wanted velocity. So let's take a look at our rules real quick. We need the direction vector for moving along that surface. So we're going to do a sweep test in the direction which is normal, rotated in our direction of movement. So we need to check our velocity. So if our velocity is, this is going to be in the y direction. If our velocity.y is greater than 0, else if velocity.y is less than 0, we're going to have else. Else we don't have any velocity in the left or right direction. If we don't have any velocity in the left or right direction, then we just have like the z velocity. In which case, we should actually just return delta t if we have no velocity in either of those directions. For now, I'm going to put a comment here, ignoring z-axis. If you're on the ground, you need to call jump to leave the ground. I guess we should also have something in here to check. So if closest distance to floor is that, but if closest distance to floor is actually like greater than a certain amount, right? Like if the floor moved on us and we still collided with like a thing there. So if we're like, if closest distance to floor is greater than like our sticky amount, because we're gonna stick to the floor, but we can't like stick too far, right? So we're gonna need to add a thing here for this. Because the floor moved too far away from us, we're no longer stuck to it. And we're actually going to need to move ourselves to the floor. So G, floor stick distance. And why don't we just set it to something gigantic at the moment. And basically what that's going to do is that's going to make it so we're actually going to multiply that by delta t. So float floor stick distance is going to be, well, we're going to need some other stuff too. Like, what if we cast down and the floor is different than the floor we thought it was? Well, we're moving in these small increments, so like delta t should be somewhere between 0 and 5 milliseconds. Regardless, floor stick distance should be... Well, that's an interesting thing. Like, we're not simulating the entire world on these 5 millisecond increments. Well, I don't think this is going to be too big of a deal. So we're going to have two floor stick distance things here. So floor stick distance base and floor stick distance dt. And base is going to be our base, like our base floor stick distance, and then the dt distance is going to be something we multiply by the frame time. So we never have like a 0 floor stick distance. If we have like a super short frame or something like that, we're not just going to come unhinged for no reason. So if the closest distance to floor is greater than floor stick distance, then we will also be in the air. So we didn't hit anything. And let's actually also separate these conditions out. Just because it's redundant to have two conditions that effectively do the same thing. But while we're kind of just in here messing with stuff, it can be really handy to have some of these things breakpointed. So you can be like, we're only going to hit this condition if, you know, this is the reason why we are no longer on the ground. So let's see. If our velocity y is greater than 0, then what we're going to want to do is take this surface normal, and we're going to want to rotate it about, like if this is y and this is z, we're actually going to rotate about the x-axis by positive or negative 90 degrees here, aren't we? So what we want to do is, can we do a transform on this surface normal? And we need to just rotate it. So how do we do that with Unreal? I think we need to make like an F rotator or something like that, and then we call like some of that. So let's see, Dashkin. I think Entity Utils does that. It's got an example I can look at. Yeah, I've got a transform. So we can set our translation. We're gonna, set the rotation to 90 degrees, and the x-axis, I believe, is what we're needing to do. And is there like a transform vector on these F transforms? So let's see. These are all constructors. Add to translation, blend with, is there get location, get scaled, inverse, multiply. There's transform f vector 4. Is there just transform rotation? Transform vector, I believe, is what we want. So let's try transform vector and see if that's what we need here. So we're going to do transform vector surface normal. So set that equal to that. And let's hopefully spell transform properly here. And we can actually kind of do this a little bit down here. So if we declare the transform above all this garbage, we can just set the rotation in these if else's and then just do our transform down here. So, and let's do this. Let's print it out. The surface normal was %f, %f. And we want this to be the movement direction vector. It's going to be the surface normal transformed. And then the movement direction, it's not was, it's is. So the movement direction is these guys. Awesome. So we've got our surface normal, we've got our movement direction. So what else do we get? So, number one, do a sweep test in our direction, which is normal rotated direction of our movement. So we need to do a sweep test for all of our components again. And the direction is going to be the movement normal direction. So we're going to just normalize this vector right here, because we need to normalize our vectors before we do anything crazy with them. So we're going to sweep these in the movement direction vector. And we're going to need to get our closest hit. So we're going to do f hit result closest. And how are we actually going to... What do we really care about? We care about the distance, so hit distance, and we care about I think that's all we really care about. I guess we care about the impact point. Alright, so hit distance, we're again going to set it to far enough. And the impact point we're just going to set to that 0 vector. Okay, so we're going to need to say if the hit distance, the current hit distance, is greater than blocking hit dot distance, then we are going to set the impact point to blocking hit dot impact point. We are going to set hit distance to blocking hit dot distance. Let's spell hit distance properly. Okay, so if hit distance is greater than or equal to our physics far enough, then we did not hit anything. I think we're using the wrong... Because we want the direction vector for this movement, but we also need to calculate how far we're going to go, right? So we need to do our float move distance, and that's going to equal our it's going to be our wanted velocity in the y direction. Yeah, that should be our wanted velocity in the y direction. And we're going to do our do the absolute value of our wanted velocity dot y, and we're going to multiply that by delta t, and that's going to be our movement distance. So we need to do sweep component, and we need to give the distance, and the distance should not be physics far enough. The distance has to be our movement distance. Why are you complaining? U paper physics component is incompatible with U primitive. Oh yeah, we need to cast these things, don't we? Well, I don't want to be casting all this crap all over the place, so instead of that, we're just gonna write some little helper functions in our physics utils, so we don't have to throw dirty little casts everywhere. We can just throw all of our dirty little casts in one place. I like that a lot more. So these will be the same methods. They're just gonna take paper physics components, because screw the rules. Excellent. Excuse me. The sneezes just come out of nowhere. As long as it works. I write the rules around here. Pause, dir, distance, primitive, and are they called hits? Hits. Pause, dir, distance, primitive, and rotation hits. Yeah, thank you. The devil is trying to invade my soul. And little did he know I didn't have one. Pawns and get out of here, IntelliSense. I don't want you covering up what I'm trying to read. That's one of the reasons why I just stopped using IntelliSense. Was because every time it pops up, it's like popping up over what you want to see, and every time you want it to pop up, it doesn't pop up. It's like you'd think after how many years Microsoft would have fixed freaking IntelliSense, but nope, nope, not gonna happen. Alright, that looks about right. So we should now no longer have to do our nasty little casts here. So where are we here? we were just doing our checks. So movement distance is here, is the velocity times delta t. Our movement direction vector is set properly. So if our hit distance is greater than physics far enough, or greater than or equal to, then we can just move to that location, can't we? So we can just say, I'm going to take a look at move object real quick and see if we can just use it. Doesn't look like it. It does a whole bunch of velocity crap. It's also playing our animations, so we're going to lose our animations here when we do this. That's fine though. So we're going to call internal set position, and we're going to set it to our start position plus our movement direction vector times our movement distance. And we're going to return delta t because we simulated the entire thing. Otherwise, let's see. If this test has no collisions, we move. If it does, alright, no, actually, if this test has no collisions, we move to the new location. Then do another sweep test downwards and move to the ground if it's close enough for us to snap to it. If we cannot snap to the ground, then we set ourselves to be in the air. Okay, so we need to, this was if there was no collision. So we will set ourselves to this current position. Then we're going to need to snap to the ground. So let's go see if we can do that. So this can be a little messy. We probably want to make a function that's like snap to ground and start calling that. So we're not going to use this for start position. We're going to need to get our new position. So what we should do here is f vector new position. We're going to have to set that equal to this guy right here. So new position. And then this is going to be the new position. We're going to cast down, and it's going to be physics far enough. We're going to have to do this for every component, so we're going to need to iterate over our components yet again and do even more raycasting and sweep testing. So we're also going to need to reset our closest distance to the floor. Where are you? Closest distance to the floor. And our impact point, I believe. So we need impact point and closest distance to floor. Alright, so if closest distance to floor. So right now we're still using our. So if this is greater than or equal to physics far enough, then we didn't hit anything, so we're flying. So again, we got like some copy pasta going on here. You know, we didn't hit anything, so we're in the air, and we're not returning 0. We're returning the full delta t because we simulated it properly. Excellent, so we are now in the air. We're also going to say if closest, we'll do another calculation here. So floor stick distance, we already have the floor stick distance. But the floor stick distance is actually just going to be equal to the base stick distance, isn't it? Because we're out of time, we've already simulated it. But let's see what it is with just the normal stick distance. but we'll throw it over here. So if our closest distance to floor is greater than the floor stick distance, we should actually go change that other one to a greater than, shouldn't we? Yeah, here we go. And we'll also set ourselves to be in the air, so the floor was too far. We couldn't get there. Fat Sack's little legs just could not reach the floor. Then we're in the air, and we're going to... I didn't hit anything. It's a floor too far. Otherwise, what we need to do is set ourselves to just a little bit above the impact point, it sounds like. Yes. No soul. Everybody in college just said I ran off of anger and hate instead of food like everyone else. Little did they know I actually just run off of caffeine. Like most everyone else. And I got that reputation after we stayed up all night playing Halo 3 one night, and everybody was just completely destroyed the next day, and I was like, oh, what's going on? You know, perfectly fine. And it's because I hadn't gone to sleep yet, so I still had energy. And everyone else had fallen asleep for an hour. And so they all felt like crap. Okay, so if we cannot snap to the ground, so we need to actually snap to the ground. So let's just do snap to ground. We need to set ourselves to just above the impact point. Is the idea. We don't want to move ourselves any higher, but we do want to move ourselves to the impact point and a little bit above it, I believe. And we're going to need to move above it, we're going to need the surface normal, and we're going to move a very small amount, out of the surface normal. So let's take a look at... Do we have a physics very small number that we want to use? We have this penetration distance thing, which we were abusing to all hell, so let's just use that. So, basically what we're going to do is this one. Oh, Adam's hanging out? Is that what's going on? Yeah, Halo 3 is a big deal. Yeah, we played way too much Halo 3 in college. We actually played more Halo 3 back at EA2D than we played. Yeah, Adam just came in. He's like, this channel sucks, and he left. We played a bunch of Halo back at EA2D. Adam wasn't a part of that, but we actually had some Halo parties. We had some Counter-Strike parties. We actually had a EA2D versus Konami, Counter CS:GO event as well, organized by one of our people. We had a lot of fun at that studio. That was great. Which is one of my things there, where it's when a lot of game developers get super busy and everything, they kind of lose track, and then they don't play any games for too long, and then they get old, the quote unquote, they just get old. Not physically old, but just mentally they become dinosaurs disconnected from reality. Okay, so snap to ground, we're going to multiply the penetration distance by the surface normal, and it's going to be the impact